Good morning, students. Continuation of chemistry, of the organic chemistry. Chemical bonding is one of the important topic for NEET and JEE, CET also. PU point of also nearly 11 marks will come from this chapter. Okay, so what is the meaning of chemical bonding? What is the significance of chemical bonding? How many types of chemical bondings are there? Or how many theories can explain about the chemical bond of the bonding in molecules? We will see in conclusion. Okay, what is the chemical bond? Just the definition. Okay, the attraction forces between two different molecules or two different atoms or same molecules we call as chemical bond. The attraction forces between two molecules are same or different. The attraction forces between two atoms same or different we call as chemical bond. That means the attraction forces between two molecules. Okay, two molecules in external space like this we call as chemical bond. We call as chemical bond. Okay, here we have the three chemical bonds by the attraction forces held by two molecules or two atoms. Okay, one is ionic bond, second one is covalent bond, third one is coordinate covalent bond. This is we called as day-2 bond. Okay, this is one type. One more type of attraction forces are there. Okay, if two molecules are having weak attraction forces between, these are strong, these are weak. Attraction forces between two molecules leads to formation of the liquids or formation of the solids. This type of attraction forces we called as intermolecular attraction forces. This type of attraction forces we called as intermolecular attraction forces. This type of attraction forces we called as intermolecular attraction forces. These are the different types of intermolecular forces are there. Dipole intermolecular attraction forces, van der Waals intermolecular attraction forces. Okay, van der Waals intermolecular attraction forces, hydrogen bonding. These are the different attraction forces. These are different attraction forces. Here we discuss about all these attraction forces in this chemical bonding. Okay, the attraction forces between two atoms or the two molecules we considered as chemical bond. Or two molecules or two atoms held by the some attraction forces are called chemical bond. We'll see in continuation those chemical bondings and what is the significance of chemical bond. What is the significance? Means importance. What is the importance of chemical bond? Chemical bond leads to minimum energy. Chemical bond, formation of the chemical bond leads to minimum energy, maximum stability. Minimum energy and maximum stability. Okay, for acquired stability also, same acquired stability also molecules involves in chemical bonding. Okay, this is the just main cause of chemical bonding is to acquire stability. To acquire stability. Then in continuation, we'll see some important theories which explains about the chemical bond. In that way, the first theory is Lewis-Kossel approach or Lewis-Kossel theory. We'll see here in continuation. Lewis-Kossel approach. So many theories are there. One is Lewis-Kossel approach, and here valency bonding theory, VSCPR theory, valency cell electron pair repulsion theory. Okay, so many are there, but in continuation we will see first important theory which explains about the formation of the covalent bond, that is Lewis-Kossel approach. Theory or approach. Okay, this Lewis-Kossel theory theory mainly explains about the formation of the molecules by the sharing of electrons, by the one point sharing of electrons. Okay, second important point, by transfer of electrons, sharing of electrons, by the transfer of electrons. Okay, molecules will form. After completion of the molecule, every molecule, after this is the first point, we'll see second point. After completion of the formation of the molecule, after formation of the molecule, every molecule should have 8 electrons or 2 electrons in outermost. 2 electrons means it is applicable to only helium. 8 electrons means it is applicable to all inert gases. Should have the inert gaseous electronic configuration of every atom or central atom. According to the Lewis-Kossel theory, after forming the molecule, every central atom or every atom should have the 8 electrons that we called inert gaseous electronic configuration, or 2 electrons, this is applicable for only helium. That molecule should be stable. That principle we called as octet principle. After the formation of the molecule, every molecule should have 8 electrons in outermost. That only says octet principle. If it not have the 8 electrons in outermost, that is unstable molecule. It exists but unstable molecule. Okay, see, and here exclusively when you are explaining the formation of the molecule, we need only valency electrons. Valency means outermost orbit electrons. What is the meaning of outermost orbit electrons? Last orbit electrons. What is the meaning of last orbit electrons? Suppose hydrogen is there, 1s1 electronic configuration. This is only last orbit, so this we called valency electron. Suppose lithium is there, electronic configuration 1s2 2s1. Here this is the valency electron. Last orbit we called valency orbit, last electron we called as valency electron. For example, beryllium is there, atomic number 4, 1s2, 2s2, here valency electrons. Okay, here just I want to show the elements of second period with the valency electrons. Second period start with the lithium. Okay, here lithium has only one electron. This is the symbol of lithium with one valency electron. Okay, next I am giving beryllium. Here one electron, here one electron. Is a beryllium valency electrons. Boron 3 electrons. Okay, carbon 4 electrons. Okay, carbon 4 electrons. Next, after the carbon, nitrogen 5 electrons. All these are valency electrons. Okay, after that, oxygen 6 electrons. Okay, fluorine 7 electrons. And here neon 8 electrons. Okay, this is what we call dot. And valency electron. Okay, the showing of valence electron in atom we called Lewis symbols. These are we called as Lewis symbols. What is the Lewis symbol? The denoting of or representing of atomic symbol, atom symbol along with the dot related to valency electrons. Dot related to valency electrons. It represents number of valency electrons present in outermost shell. Always first group element have only one valency electron. Second group elements have 2 valency electrons. Third group elements have 3 valency electrons. Fourth group elements have 4, 5, 6, 7, 8. These we call Lewis symbols. In another way, this we call Lewis dot symbols. Lewis dot symbols. And in continuation, how will represent the molecules by using Lewis dot structures or Lewis dot symbols? These are atoms. How will represent the molecules? Okay, next. Lewis dot representation. Lewis dot representation of molecules. When you write the Lewis dot representation of molecule, just we write every atom with an electron, but the electron which are involved in the bond, those we can't write with dots, those can be write with bonds only. Those can be write with bonds only. See, what is that? When you are writing the Lewis dot representation of molecules, just we write the valence electrons as usual with dot, which are involving in the bonding. Those we can represent with bond, not the dot. Not the dot. That is one of the important point of this Lewis dot representation of molecules. Okay, see here. First I want to show the hydrogen molecule, H2 molecule. H2 molecule. Hydrogen has only one lone electron in outermost. Hydrogen has only one lone electron in outermost. Okay. Here, hydrogen molecule means here one lone electron, here another lone electron. These two are involved in the reaction, so we get the hydrogen molecule. We get the hydrogen molecule. Here it gets, this hydrogen has two electrons, this hydrogen has two electrons, so it gets helium electronic configuration. Helium electronic configuration. Helium is inert gas, so it is stable. For example, you take water molecule, H2O molecule. This is Lewis representation of hydrogen. Lewis representation of oxygen. Oxygen has 6 lone electrons in outermost. Okay, here H with dot, H with dot. This lone pair of electron, only valency electron, non-bonding electrons which are not involving in the reaction. Those only shows with the dots, remaining as usual. This is the H2O molecule. How many electrons are present in oxygen here? Okay, already 6 are there, coming from 6 plus 2, 8. It follows octet rule. That means 8 electrons are present in outermost. Hydrogen also follows helium inert gases electronic configuration, so it is stable. It is stable. Then see the ammonia molecule. NH3, ammonia molecule. Here nitrogen, one lone pair of electron. Here 3 hydrogens, 1 electron. Here hydrogen, 1 electron. Here hydrogen, 1 electron. Nitrogen has 5 lone electrons. See, it forms bond, sharing of electrons. It also forms bond by sharing of electron. It also forms sharing of electron. 3 plus 3, 6, 6 plus 2, 8. It also follows octet principle. 8 electrons, more stable. Follows octet rule and 8 electrons, more stable. Then in continuation, we will see the one more important molecules. Okay, here I am taking methane, CH4, methane. Okay, here carbon, here hydrogen, 1 lone electron, here also hydrogen. Carbon has 4 valency electrons. See, it forms 1, it forms 1, it forms 1, it forms 1. There is no valency electron. It also follows octet principle. And stable. Suppose you take carbon tetrachloride molecule. Carbon is the atom. One lone, two, three, four lone electrons. Here chlorine. Here also chlorine. Here also chlorine. Here also chlorine. Chlorine is 17 group elements. So it has 7 lone electrons. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It forms bond. It forms bond. It forms bond. It forms bond. This is the Lewis dot structure of carbon tetrachloride molecules. Lewis dot structure of carbon tetrachloride molecule. Every molecule will represent like this only. Not only this one, every molecule will represent like this one. First, identify the central metal atom and write all the surrounding atoms. Okay, which are involving in bonding. We can't write other. We write like this. Which are not involving in bonding. We write like this. Okay. Next, disadvantages of Lewis-Kossel theory. Disadvantages of Lewis-Kossel theory. Okay. This is also important. Disadvantages. First, it fails to explain incomplete octet rule. Incomplete octet electronic configuration containing molecules. Incomplete octet electron configuration has molecules. Fails to explain. Second one, okay, it fails to explain extended octet principle of molecules, of extended octet principle of molecules. It also fails to explain stability of incomplete. Here write stability, here also write stability. Stability of odd electron containing molecules. Stability of odd electron containing molecules. Fails to explain geometry of molecules. Geometry of molecules. And stability of transition metal cations. Transition metal cations. Stability of transition metal cations. What are the disadvantages? One is it fails to explain incomplete stability of incomplete octet electronic configuration molecules. And here stability explain extended octet principle molecules. Next, chemical inertness of noble gaseous compound. Noble gas compounds. Noble gas compounds. And relative stability of molecules. Relative stability of molecules. These are the important disadvantages. What first one, it fails to explain stability of incomplete octet electronic configuration of molecules. This is of, not has. Okay. Next, stability of extended octet principle of nucleus, stability of odd electron containing molecules. Okay, geometry of molecules. Next, chemical inert stability of transition metal cations. Next, chemical inertness of noble gas compounds. Next, relative stability of molecules. Next, in continuation, we'll see these. In continuation, we'll see the complete explanation of these seven. Okay, just see. We have first 3 or 4. First one, incomplete. Okay, stability of incomplete octet electronic configuration of the molecule. Suppose beryllium chloride is there. This is the Lewis dot structure of beryllium chloride. Here forms bond, here forms bond. This molecule is stable, but beryllium not having the 8 electrons, just it has 4 electrons in outermost, but it is stable. Okay, Lewis kossel theory fails to explain the stability of this. Next, borane trifluoride, boron trichloride, boron tribromide, boron triiodide, aluminium trichloride, gallium trichloride. All these are having only one structure. Here I am giving boron trifluoride and oil, boron trifluoride, fluorine. Here 7. Here also 7. Boron has 3 electrons. It has only 6 electrons in outermost. It has 6 electrons in outermost after the forming of complex. But it is stable. It is stable. This theory fails to explain stability of such type of molecules. Next, second one, it fails to explain stability of extended octet principle. What is the meaning of extended octet principle? After the forming of complex, the central molecule has more than 8 electrons, but it can exist. It forms due to the presence of only valency d electrons like that. But this theory fails to explain formation of those molecules, stability of those molecules. Here I am taking PCl5, SF6, IF7. Okay, see PCl5, phosphorus 5 electrons. Chlorine, here 1. Chlorine, here also chlorine. Here also chlorine. Here also chlorine. This is the Lewis dot structure of phosphorus pentachloride. In here it has 10 electrons. It is impossible. Just by sharing of the electrons it can exist. This is different. But the stability of this molecule not explained by Lewis-Kossel theory. Here also SF6 means 12 electrons are present in outermost. Here 14 electrons are present in outermost. But it can exist. This theory fails to explain stability of this type of molecules. Such type of molecules. This is the second disadvantage of Lewis-Kossel theory. Third disadvantage, stability of odd electron molecules. Nitric oxide is there. Nitric oxide means this is we call nitric oxide. Here we have the odd electron, but it is stable. Why it is stable? It fails to explain stability of this type of molecules. NO2 also, not only NO2. Okay, ClF3, ClF5, BrF5. All these are odd electron containing species. All these are not stable. It fails to explain stability of such molecules. Next. Okay, it fails to explain stability of transition metal ion. Fe plus 3 is there. Fe plus 3 T black element we call transition metal. Okay, first I will write here iron electronic configuration argon 3d6 4s2. Okay, that means here iron plus 3 means argon 3d5 only, and here we write, what do we write here? 3s2 3p6 3d5. How many electrons are there? 6 plus 1, 6 plus 5, 11, 11 plus 13 electrons are present. But it is stable. Okay, it fails to explain stability of d electron, stability of these molecules, stability of transition metal ions. Okay, it doesn't explain about the geometry of molecules, and it fails to explain relative stability of different molecules. Relative stability of different molecules. These are the important disadvantages of Lewis-Kossel approach or Lewis-Kossel theory. Okay, mainly explains about the covalent bond. Okay, just I touched here covalent bond, but in continuation I will explain complete. I will give the complete explanation of the covalent bond. Thank you.